Ministry of Education, Government of India, and IIT Kharagpur. It is my great pleasure to extend a warm welcome to all the dignitaries, invited speakers, distinguished guests, and participants to the SPARC Conclave. May I kindly request all the dignitaries and the participants to take their seats so that we may begin with the proceedings shortly. I also humbly request everyone to please keep their mobile phones in silent mode during the proceedings. Thank you, everyone. Now, I respectfully invite our chief guest, Professor David Quer from ESPCI Paris and École Polytechnique. Please give a huge round of applause. Our guest of honor, Shri Armstrong Pame, IAS, Joint Secretary, Department of Higher Education, Ministry of Education, Government of India. And Professor Abhibrata Mukherjee, National Coordinator of SPARC, to kindly come up to the dais. I request Professor Abhibrata Mukherjee to welcome the dignitaries on dais with an uttariya and a bouquet of flowers. Let us commence this auspicious occasion with the ceremonial lighting of the lamp, followed by the Saraswati Vandana, invoking wisdom and blessings for this conclave.
You have to put on the switch, I think. Put on the switch, yeah. There is some switch, you have to put on the switch. It is not connected. Hey, light, Ajit, light has to control. We will play the...
शुक्लां ब्रह्मविचारसारपरमाम् आद्यां जगद्व्यापिनीं वीणापुस्तकधारिणीमभयदां जाड्यान्धकारापहाम् हस्ते स्फाटिकमालिकां विदधतीं पद्मासने संस्थितां वन्दे तां परमेश्वरीं भगवतीं बुद्धिप्रदां शारदाम्
I request Professor Abhibrata Mukherjee to welcome the dignitaries with an Uttariya. Please give a huge round of applause.
May I now request Professor Abhibrata Mukherjee, National Coordinator of SPARC, to provide an overview of the program and the key highlights of this SPARC conclave.
Good morning, everyone. It's actually Honorable Chief Guest, Professor David Quer, who has traveled all the way from Paris. He reached at 8:30 a.m. this morning, and straight away he's here. Those of you who work with fluid mechanics, and particularly droplets, you are probably standing in front of your God, physically, not in a virtual mode. Mr. Armstrong Pame, IAS, Joint Secretary, Department of Higher Education, Ministry of Education. For the last 1 year or so, he has been the driving force behind SPARC, and all the PIs should individually thank him. All the goodies that have happening, consumables, prototype fund, many other things, call open round the year, it's all because of Mr. Pame. And then finally, namaskar from the email and WhatsApp guy of SPARC. It's great to see many of you in person. Thanks for agreeing to our invitation over a very short period of time and traveling. I know each one of us are busy. Each one of us are teachers. And for the knowledge of Mr. Pame and Mr. Quer, Mr. Pame of course knows, the SPARC is an international research and mobility grant of the Ministry of Education, Government of India, in which international professors come and spend time with us. But not only that, our PhD students can actually go back and spend time, long time, 3 months to 6 months, in the laboratories of the international professors. So this gives or empowers our students with the exposure in the best-in-class laboratory facilities across the globe. And today, this room, we are having SPARC PIs and SPARC students. The PIs who have hosted some international visitors, definitely, and almost all the students have gone abroad to get some training entirely funded by the Government of India into some international lab or the other top-class, world-class universities. So it's a gathering of these people. Also, it's 8th of March, International Women's Day. So my heartiest greetings. I do not believe in segregation, but my heartiest greetings to every woman present over here. And you will be delighted to know that amongst the participants, we have close to 100 female participants, about 35 female SPARC PIs, and about 65 to 70 female SPARC students. I would request everyone to give a round of applause. And I think SPARC is a program which now, because of your very active participation and collective effort, is doing very, very well. It started in 2018. IIT Kharagpur is historically associated with it because it was incepted by our former director, Professor Chakrabarty, during his time. However, just like everybody else, SPARC was very, very badly hit during the COVID period because after all, it's a mobility grant. And there are a lot of phase 2 PIs. I call them the trouble phase because these are the unlucky folks in a way that they submitted their proposal in 2019, but you are also lucky that you got the funding in 2023. Then you are again unlucky because I am at the helm of affairs, so you have to reply to my mails and messages and whatever every now and then. After that, ever since phase 3, I think things are pretty streamlined. And SPARC has also ignited significant amount of bilateral interest in phase 3. We actually had a dedicated track with UK, SPARC UKD. Phase 4 onwards, we are having a sustained dedicated track with DAD for co-funding of projects with Germany. We call it the Giant. Don't just look at my shape. It's the German-Indian Academic Network for Tomorrow. It's going to run for 5 years. And several other countries are also interested in having some similar tracks. So with that, I think I welcome you all again to IIT Kharagpur, not exactly in our campus, but IIT Kharagpur Research Park in Kolkata. And repeatedly, I had to tell in the WhatsApp group, please don't book a ticket to Kharagpur. Please come to Kolkata. Professor Mehta was just yesterday, in fact. I know so many of you by name. I will talk to each one of you. We will have a lot of photographs, a lot of food, and have good time. And also, apart from food, please have an academically stimulating and fruitful meeting, make networks, not only with your international partners, but with all SPARC PIs who have gathered here from across the country. Literally, sir, I'm proud to say that there are people from Kashmir. I see Rifat over there. Kanyakumari, I'm not very sure, but Trivandrum definitely for sure. Mizoram in the northeast to Gujarat in the west. That's SPARC. I call it fondly, one nation, one SPARC. Thank you very much. Jai Bharat, Jai Hind.
Thanks a lot, sir, for briefing us about this conclave. Moving on, I request Shri Armstrong Pame, Joint Secretary, Department of Higher Education, to kindly enlighten us with his thoughts on this SPARC conclave.
Good morning, madams. Good morning, sirs. I welcome from the Ministry of Education, Government of India. I welcome each and everyone present here, especially to all the women on this auspicious day of the International Women's Day. And more so, I think 90% of the women present here are in STEM education, correct? So more power to you. You have chosen the difficult part. You have chosen a path less taken, and you are thriving and you are doing well. The fact that you are invited to come for these sessions, that you are invited for this conclave, shows that you have proven your worth. You have proven that you are worth to be invited for this. So kudos to all of you, and I'm sure you'll be able to take it forward. Thank you, Professor David. I know you must be really tired, but hearing a little 1-minute introduction of yours from Professor Abhibrata, I'm so happy that people like you have taken up the honors to partner with the scientists, the academicians from India. Speaks a lot of the emerging talents and the potentials that my country produces and continues to produce. I look forward for many more such collaborations in the days to come. In fact, when my Honorable Prime Minister and your President met on the 17th of February in Mumbai, just few weeks ago, they talk about bringing together the academicians, the innovators, in one place. This year we're going to have something called Bharat Innovates. We will be having this at Nice. Most likely the date will be decided very soon, but tentatively it's from 14 to 16. With all of these occasions, bringing the innovators together, the scientists, the academicians together, the relationship between the two countries will continue to flourish. And in fact, we are proposing to the France side to introduce a counterpart of SPARC, like we had already done with Germany, like we had already done with UK. So our proposal will be going very soon to your country through diplomatic channel. And I hope this will work out. And then I can see so many more Professor David, like you, from France in the next national conclave. Taking forward from here, we in the ministry, okay, first of all, I have to admit that I feel really overwhelmed to be sitting in, to be here in your midst. I just met one of the professors who taught my secretary, Dr. Vinit Joshi, when he was a student at IIT Kanpur. Where is Sir gone? I don't know. Yeah, Professor Gautam. Yeah, Sir is there. So I think putting together all the number of years of your experience, whoever is here, I think it must be close to 5,000 years, something of experiences. And that too, not in a easy subject, but in a hardcore STEM educations. So to be speaking in front of all of you, I feel really, really small. I'm only a graduate. I graduated, of course, with physics, but I decided to write UPSC, so here I am. In the ministry, I'm given this responsibility to look after this scheme called SPARC. The only thing I saw was the fund utilization was very low. As a bureaucrat, as a civil servant, my only duty is to speed up. My only duty is to push. I did not know the procedures of how things are done. My only interest is every 2 weeks when I review my expenditure, the money has to be spent. So please pardon me if you have got several messages in the last 6 months from Professor Ravi Brata that you have to finish your money in the next 48 hours, 72 hours. So those messages has not come from him, but from me, saying that because my performance is also measured on how much I'm able to execute what the government has asked me to spend. So when I see that no money ever is spent fully for the last 4 or 5 years, what is given to SPARC, my intention is that every money that you delay, every single penny that you delay in the expenditure means a loss to the students and faculty. My only interest is that you guys should get your money in time so that the project should be done and carried forward. So this is my core interest. And hopefully in the next few days from now, your SPARC project for the next 5 more years will see the enhancement in the budget, and then you'll be able to do much bigger things. For the women in STEM education, yesterday a journalist in Chennai asked me, why are you so focused only on STEM? The journalist obviously is a humanities student, so maybe he must be having, this intention that we're not focusing on humanities. Of course we do, but the government's focus is not only producing students who will be job seekers, but our target, our focus, as clearly specified in the NEP, is to be producing graduates who will be job creators too. In this process, I believe STEM has the best potential to create people, to bring up people who will be a job creator. Like it has been done in the past, it's being done now, and even in the days to come, STEM has the best possibility to bring out, the best chance to bring out students who will be job creators. And that's why this year, in the budget which has just been announced, the government is laying a special emphasis on supporting students in STEM education. And today being an International Women's Day, my secretary also will be speaking on this. Government has introduced in the budget line, 500 capacity hostel for girl students in STEM education. 500 bedded hostel for girls in STEM education in all the districts of the country, 780 plus. I hope with this, the number of women getting into STEM education will enhance, will increase. The reason is very simple. STEM education requires you to be spending some of your nights in the laboratories, spending at odd hours, coming at odd hours to the labs. So the mobility for women becomes a challenge. To solve many of these issues, the government has given a special emphasis on this, and we're gonna, in fact, tomorrow is the budget discussion on this, and I'll be moderator for this session, and we're gonna come out with, we'll be taking an inputs from experts. Many of you, if you would, especially the women's, if you would like to contribute certain ideas, please do so. We'll be happy to incorporate before we start the implementation of these projects. So government is laying special emphasis on all of this, starting with many of these small initiatives. And we look forward that whatever initiatives the government is doing today will be able to fructify. Lastly, yesterday I was at Loyola College. I was pretty impressed with the way they light the lamp. How they light the lamp? Basically, there was no lamp. Flower pot, we did the, watering of the flower pot. Great. Today, the lighting of the lamp is different technology again. For the people in SPARC, ministry has been emphasizing, has any of your product, has any of your ideas been translated into market product? Because for a bureaucrat like us, when we evaluate the continuity of your program, we only want to see the final product. We do not understand the rigor of how many hours you have gone through in the labs. We want to see where is the product. Any of the product that has gone into the market out of SPARC? Of course, Professor Ravi Bratta was trying to give thousands of explanation, this and that, but finally we're interested in Kahai product. So my earnest request to people who are in this project is, if you can convert some of your ideas, some of the patents that has been granted into market-ready products, take it forward, introduce it at the international, national level, become a big thing. Then I assure you that government is there to make SPARC into a raging fire. That's what we want to term it. So all the best, and I'm sure such national conference will be organized more often. I've been telling Professor Ravi Bratta that you should, every 2 months, you should have the potential to bring Nobel laureates and give talks. Government has no shortage of money. That's what we wanted to tell you. And all the best for this conclave.
Thank you so much, sir, for your enlightening words and valuable insights with us. I now request Professor Abhibrata Mukherjee to kindly present a memento to Shri Armstrong Pame as a token of our sincere gratitude for his continuous guidance and support to the SPARC program. Now, I request Professor Ravibrata Mukherjee and Shri Armstrong Pame to join the audience.
So before I get down, I have been very politely told that leave the stage now because Professor Quer will give his presentation. Mr. Pame, sir, there is a small prototype demonstration is going on just outside. And some of the technologies, there are I think 12 or 14 stalls have been put up, but Ashish, where are you? So Professor Ashish Bhatnagar makes cells with Australia again, joint collaboration with Monash, I think. Professor Bharati Raja, where are you? So he has some wireless devices which have come out of the SPARC project, so we will show it all to you. Now I'd request Professor Chirodip Bakli to kindly take over the technical session.
Good morning, esteemed colleagues, distinguished guests, and fellow researchers. It gives me a great pleasure to welcome you to the first technical session of the Maiden SPARC Conclave held in conjunction with the Platinum Jubilee celebrations at IIT Kharagpur. It is a great privilege to introduce today's speaker who has profoundly shaped the physical understanding of the world around us as we know of it today. Professor David Quere is known for many things, and our audience who is working on fluid mechanics, soft matter, or in the realms of surface science, his name requires little introduction. His work is synonymous with elegant experiments, deep physical insight. His annual review articles on wetting and roughness and Leidenfrost dynamics have become an essential reading component for the generations of researchers in the field. Professor Quere is widely recognized as a pioneering researcher in the field of wetting, superhydrophobicity, and droplet dynamics. Through beautifully designed experiments and profound physical intuition, he has revealed physics behind phenomena that we observe. Remarkably, water repellency of lotus leaves, fascinating dynamics of droplet impacting and bouncing off highly repellent surfaces. His work has not only advanced the fundamental understanding of capillarity surface tension, but has also inspired numerous technological innovations ranging from self-cleaning materials to advanced anti-icing and surface engineering technologies. The SPARC initiative is founded with the vision of strengthening international academic collaboration and bringing together leading researchers from across the world. It is therefore particularly fitting that we have today an academic luminary like Professor Quere, whose presence is a valuable opportunity for all of us, especially the young students and early career researchers who can learn from the foremost experimental physicists of our time. And as of our affectionate linguistic tradition at IIT Kharagpur, join me in welcoming the god of drops, bubbles, pearls, and waves. Please extend a warm welcome to Professor David Quere. Professor, the floor is yours. There is a pointer. They're getting the connector for you.
स्लाइड शो कीजिए, हम डाल देंगे. जस्ट अ सेकंड सर.
Well, it's a huge pleasure to be here. My second time in India. First time was 2 years ago in Chennai, and I must say I have only friends in this country, colleagues and friends, and also former students. My first PhD students who were not French were Indians, actually. So I was asked to speak in front of you, so I'm very honored of that. I didn't know exactly what to present. I was told it's a technical session, so it has to do with science, but I chose something I hope that can be shared by everybody, including people who are not working in the field. The field being a mixture between physics, soft matter, fluid mechanics, and in a sense technology and biomimetics. So I'm going to discuss the way a few creatures are somehow dominating the laws of surface energy, something which was invented very long ago and which is very subtle, but useful to control when you are small, when you are at the scale of drops and at the scale of bubbles. And I will start by a very general comment, which is the fact that water at a small scale, at the scale of what we call drops, is sticky. So the first kind of proof of that, so it seems to be jammed here, but how could I do? Nothing happens here. Well, I'm going to switch off this thing, come back. So it's jammed. You see, it's
Escape once and then
what?
get out of the presenting mode.
Yeah, so okay, it's okay. So my first proof of that is dew formation. So you take a cold solid and the water from the atmosphere condenses on this cold solid, and what you see, of course, is drops, and these drops are growing, they are merging, but they clearly stick to the substrate. It can be inclined, for example, ophthalmic glasses, which are nearly vertical, and it sticks, we could say, at any scale, at least at the sub-millimetric scales where we find these drops. A second example, which is even more daily life example of sticking drops, is what we observe at a much larger scale, at the scale of raindrops, when they meet an inclined solid. So, for instance, a window pane or a windshield or anything like that. So in this particular case, it's plastic, and when water goes to the plastic, it forms a little lens, but this lens does not move down. And the person who understood this phenomenon, so it was said earlier, we are March 8th, was this lady, Agnes Pockels, and she was not allowed at that time to work at university. This was in Germany, in Göttingen, and so she was doing experiments in her kitchen, actually. And she sent her results to Lord Rayleigh, and Rayleigh was so impressed by the discoveries of Agnes Pockels that he obtained that she could publish in Nature what she did. And in this particular case, she was the one who understood that the reason why these drops are not following the slope, are not falling down, is the fact that they stick to the defects of the solid. The reason is not the solid itself, is the fact that the solid has defects, and so because of these defects, there is a possibility of deforming the drop at a very small scale, the scale of the defect, which induces an adhesion force. Of course, if drops are larger, they move down because of gravity, and it will be the case of this one, and this is a real-time movie. This is water. The slope is very large compared to the slope of a river, for instance. However, you could see that the speed is quite small. And so this is another kind of difficulty to understand why the friction is so high, and it also has to do with the vicinity of the so-called contact line, this place where you have the meeting between solid, liquid, and vapor. this was first described by Scriven more than 50 years ago, and let's say the formula for the speed of the drop is still discussed. So these are very elementary things, always close to us, with important applications. However, it is still discussed. What I'm going to do is to get rid of all these complications. I'm going to restore the mobility of water, and to do so, I'm going to follow what the little insects did. So, first part will be about cicadae, okay? These are relatively big animals here on the trunk of a tree, okay? And they are very difficult to see because the color of the body is very close to the color of the trunk. And this is absolutely necessary to survive because, of course, they are very noisy, as we know, and so the birds would like to eat this flesh here, and they hide just by getting the color of the trunks. And the wings are highly transparent to avoid that they betray their presence there. And so the reason of the transparency is that the wings are covered by a texture which is quite amazing. It's a sub-micrometric texture to be transparent. And to be highly transparent, to be non-reflective, it consists of little cones, a dense array of nanometric cones. So this provides anti-reflective properties, but also it turns out that it's very hydrophobic. And if you place a drop of water on that, which of course, if it is rain, will be at a much larger scale, let's say 1 millimeter, where you see here 100 nanometers, then you will see something which is very close to be spherical. But it's more than that, and this was discovered by Chen in a very beautiful paper about slightly more than 10 years ago, that at a very small scale, at the scale of dew precisely, where water is so sticky, when there is this merging event, which will take place in the red circle here, there is a possibility that these drops, the merging drop is jumping. Okay, so this is fabulous, of course, because there is no source of energy, and spontaneously, the dew, instead of sticking, jumps out of the solid. So it would be called an anti-fogging material. And so this is something you would like to explore, because in the original paper of Chen, it said that it happens sometimes. And so the question is why, and is it something which is massive, or is it something which is relatively marginal? And so for that, you start to design a solid which is about the same, little cones, plus, so we could say this is physics, plus chemistry, and chemistry is something which is at a molecular scale, and which covers all these cones and make them hydrophobic. So you have a mixture of hydrophobicity and texture. And now you are going to do the following experiment. You put this sample in a fridge. So the temperature of the fridge is 4 degrees, and you put it out of the fridge, and you let the water from the atmosphere condense. And so this is a tiny drop, okay? And the hope is that it will remain more or less spherical. So I'm going to show you a picture which took us 1 year to be taken. It's not an easy experiment. It looks very easy, this experiment, but it's not so easy. And after 1 year, we could see that at the scale of 10 micrometers, which is a scale of drops in a cloud, so really very small drops. Even some of them are even smaller than that. You see that all of them are extremely spherical. So it means that this surface is very hydrophobic, ultra hydrophobic, even for drops at a very small scale, which is a very big challenge. And so now you have to think of what we saw earlier, the fact that as time goes on, because we maintain the temperature of this solid to be low, water continues to come to the surface, all these drops are growing, they merge, and you could, if you are optimistic, you could say, oh, it seems that now the adhesion is so small that they should be very mobile. So this is a top view of that. So it's a top view where you are going to see many of these drops growing and merging here on the cones. And to have a comparison, you do the same on pillars. Okay? And these pillars have the same size, the same chemistry. The only thing which changes is the geometry. And the real duration of this movie is 45 minutes, so it's a long experiment. And of course, it is accelerated here. And what you see at the very beginning, it's very similar. But after a few moments, it's very clear that there is a big difference between the two situations. And in particular, if you look on the right, you are going to fix two of these drops when they are merging. And I would say that the probability that they are leaving the substrate seems extremely high. Nearly always, they leave after they merge. While here, they don't actually. In these movies, you have 5,000 coalescences, and in these ones, 99% of the drops are leaving. On this one, 0.1% of the drops are leaving. Okay, so it's extremely different. And so the reason is just the fact, from very basic principles, that when two drops are merging, they lower the surface area of the system. One drop has less surface area than two drops. And so there is an energy which is there, which is surface energy, and which can be transferred efficiently in kinetic energy because there is nearly no adhesion, and the role of viscosity is extremely small. Why? Because it's water, and water is a very fluid system. And if you measure the probability of leaving, this is this number, as a function of the size of the drops, you see that it's a universal function which has two properties. One is this probability is extremely high, close to 1, and it drops to 0 when the radius becomes, let's say, about 1.5 micrometers, which is, of course, a very, very small quantity. It has to drop at some point, okay? And so these are the two metrics to quantify the efficiency of these anti-fogging materials. The fact that even tiny drops are leaving first, and when they leave with a very high probability. And so, reason, if I come back to the cicada, why did the cicada invented something like that? It's not clear. It's not clear. My colleagues from Duke think that this has to do with another property which is brought by that, which is, well, first, obviously, the fact that dew could betray the presence of the cicadae because it's white, okay? It's like a 2D cloud, we could say. But the second reason is that since these drops are leaving the wings, they clean the wings. And so all the little particles of dust, and you can do this experiment, you add dust, and you see that when they are leaving, they take the dust with them. And so you have very clean wings, which also contributes to their high transparency. My second example will be taken from an animal which is much smaller, which is called an aphid. This is an aphid living on leaves. And I'm going to be interested in something which could be a bit disgusting, but in this particular, which is not, which is the excrements of the aphid. And so the excrement is going to be here, okay? You can look, it's okay. It's a tiny drop, okay? Where is it? It comes, I think. Could you see it? It's very transparent, and it is called by anthropologists honeydew. Okay, very interesting name. Dew has to do with the size. It's very small. The aphid is millimetric, and so this is submillimetric. Plus honey has to do with viscosity. It's very viscous. The viscosity of honey is at least 1,000 times the viscosity of water. Okay, so you have something which is very viscous, which is small, so it's highly sticky in principle. And of course, the aphids have to get rid of these excrements. And so if the excrement goes to the leaf, after some time, the leaf will be completely sticky, and the aphid, horrible fate, will be trapped by its own excrements. Okay? So it has to invent something, and this something, I have no movie about that, but is here. It covers the honeydew with very small particles, micrometric particles of wax. So now there is also a texture, but very cleverly, the texture is on the liquid. So you place this texture on the liquid, which means that if this liquid goes to somewhere, let's say the leaf, it will not contact the leaf, because it is somehow protected by these little particles. So this is something you can reproduce at a larger scale. These are little grains. By the way, these are natural spores of a moss. And you try to mix water with this powder. And because the powder is hydrophobic, you do not succeed. The powder goes to the surface of the drop. And then you can transfer the drop on any surface, for instance, this one, which is there. It does not wet anymore the surface because it does not touch the surface. It is protected by this monolayer of grains. And then you can play with these marbles, liquid marbles. And if you try to merge them, they cannot because they are, I said that earlier, they are protected by the powder. So you have here a very interesting object, which is a drop with very little contact with the substrate. And you can be interested in the mobility of that. You remember that water is sticky, and suddenly you have something which should be a non-stick variety of water, or even better, of viscous water. And from now I'm going to consider viscous water, which is glycerol in this case. It could be honey, something which is 1,000 times more viscous than water. Just to give you orders of magnitude, olive oil is 80 times more viscous than water. So you see this is much more viscous. And so here you are going to see a race between two of these liquid marbles. It's a top view. They are placed on an incline, and this incline is tilted by 2 degrees, very, very small angle. Earlier it was sticking, now it's moving, but very curiously, the little ones are quicker than the big ones, which is extremely curious when you think of viscosity, because when you reduce the scale of things, viscous effects becomes more and more effective, and so you always expect the little ones to be smaller. So they are not only relatively quick, predicted that about 25 years ago without knowing it was possible to make these objects. I discussed with him a few times, and he was so happy to discover that experiments could be done. He was thinking it's a purely theoretical conjecture, and the idea was based on the fact that when you look at the object, there is a little contact, even if there is no wetting, just because of the weight. And the weight, of course, tends to push the liquid close to the solid, and this creates a contact zone which varies as the square of the radius. And this is very, very unusual. In particular, now if you take the surface area, L squared, it is R to the 4, a very big power, and said in a, well, a bit too quick, I must say, I must confess, this explains the law that he found, which is extremely curious, that the velocity of this object, which is dictated by a balance between gravity on the one hand and viscosity on the other hand, is such that when the radius is smaller, the velocity is larger. And so you come to a conclusion which is very curious. These marbles are quick because they are small. Okay? And now you are going to follow them more carefully. So you are going to follow the position of such a marble as a function of time. And this is this position as a function of time. This is time. And you have a straight line which defines a constant velocity. And if you change the slope, you change the velocity, which is very natural. If it's more steepy, of course, the velocity is larger. So you see, this value is 17.5. So of course, it means something. It means that maybe something curious is going to happen at 18, okay, or 18.5. I don't know. And so this is the case. If I increase a little bit the slope, this is the new trajectory. Okay. The velocity, which is now a mean velocity, is much, much larger. There is a factor which is at least 10, okay, plus it's wavy. Okay, so something very curious happens. It's not only quick, it becomes super quick, plus with something to be explained. Or just to show you pictures of that, this is a substrate tilted by 12 degrees, another one by a factor 3 times larger. The camera is tilted by the same angle, so you don't see the tilt. And you are going to see what's happening. It's very small, but it's visible. So this is the drop on one case. This is the drop on the other case. Clearly, there is not a factor 3 between the two velocities. This is very clear. And now if you look more carefully at the quick regime, which is interesting, you see that these drops does not only move, but it accelerates. And it does not accelerate because of gravity, it accelerates because of something else. Remember that it's very viscous. And what is this something else? It's the fact, which is very typical from the subtle physics we have here. It's the fact that the contact, remember I discussed a little bit the contact, becomes itself a dynamical quantity. So this is a contact made by such a liquid on the solid as a function of the velocity. And you remember I gave a formula, and this formula was independent of the velocity, so this is this value. But when the velocity becomes larger, because you increase more the slope, then the contact decreases. If the contact decreases, there is less friction, so the velocity increases more, and you understand that you enter something very curious, which is an instability. Why is it like that? Well, it's like that because viscous dissipation occurs close to a solid in the L region, but these drops are also rotating. This was another discovery by Mahadevan. When they are viscous, they are rolling. And the title of his paper, his famous paper, which was, by the way, so new that it took 5 years to be published. It was refused everywhere. Okay, so it's sometimes it's a bad sign, but sometimes it's a very good sign. Okay, and so the title was rolling droplets, so a very key thing. And so this is rolling, and so it means that constantly this drop has to make a new L region, and this takes time. It takes a time which is L over V. Okay, and so if the velocity becomes large, well, there is not enough time to make a new L region from the static point of view, and L become a dynamical quantity, and so it can be reduced. And so you immediately understand that the fact that the drop is viscous implies that it takes more time to make this L region. And so you are getting to a paradoxical conclusion, which I like a lot, which is that these marbles are quick because they are viscous, and not despite their viscosity. Because they are viscous. If they are viscous, it takes time to make a new L region, and so the L region becomes small, and if it becomes small, you kill viscous effects. And so this is the first thing to say. The second thing to say is, so they are quick, they are extremely quick, and they are rotating, and so there is centrifugation. And here I'm very happy to cite another glorious person from India, who is Chandrasekhar. Chandrasekhar thought a lot about what is the shape of a revolving drop because of centrifugation. Centrifugation tends to make the object larger, but surface tension opposes that. And when you look at these drops, you see that they are growing as a function of time. They are not only accelerating, they are also growing. It's clear because of this oblique line. And you can see a white spot at the center. It's first a globule, then it becomes a disk, then it becomes a torus, and after it is a torus, look at that, it takes off, and it becomes a bilobe, and it comes back with some impact, and you restart all the process. And so you have all these successive shapes, and this explains why my curve, if you remember, x as a function of time was wavy. This was betraying the succession of shapes, each of them has some velocity, and in particular when it comes back to the globule, which is there, because of all these impacts, you dissipate energy, and so the velocity becomes small, and then it deforms, and everything starts again, and it can become quick. Well, my final part will be slightly shorter, and it will be a third animal, which is a spider. And not only a spider, actually, a few ones. So I was interested in the mobility of drops, and I said, well, a good way to get drops very mobile is to avoid the contact. which seems a very simple statement, but we saw practical ways to do that. This is one point of view. Another point of view is to say that if we have water close to such a solid, we can say that the air which is there, which is nearly invisible, we don't think of air, but it's there, is wetting the substrate. We could say that. Said differently, if we take such a solid and we place it underwater, we should have a film of air staying close to the solid. And this is true. If you take such a solid and you plunge this solid inside water, this is this experiment, you see that inside water, my solid is shining, and it's shining because it gets covered by a little film of air. So this is exploited by animals. I'm going to cite 3 of them. The first one is Notonecta. Notonecta is a kind of a big insect which, when it is try to be caught by a, let's say, a bird, sometimes can plunge in a pond, and it hides itself in the pond. So this is underwater. It's shining, obviously, and so the body of Notonecta is super hydrophobic, which means in this context super aerophilic. And if you calculate the quantity of air which is trapped, it has to do with the size of the texture on the body of Notonecta. You find that the quantity of oxygen which is there is enough to survive for 15 minutes typically. And Notonecta stays maybe 10 minutes. And 10 minutes is huge compared to the patience of the bird. So the bird is somewhere else, and so Notonecta can go out and be safe. A second example of that is water shrew. And this is a little shrew, so it's the smallest mammals, okay, 2 centimeters. And so the temperature of the body is nearly 37 degrees, so they of course have a very big surface area compared to the volume, and so they have to eat constantly. It's a nightmare, okay? And so they eat where they can, and in particular, when there is water, they plunge and they try to find something. This is the shrew, which is hunting underwater. You can see. So it's traveling, and it's shining. So again, clearly, the fur is very hydrophobic. And at some point, it will find a worm. I'm going, yeah, maybe you see the worm. So the worm feels something, actually. He's a bit anxious. And the shrew comes back. And so she saw probably something here, because now she's interested in this region. And finally, despite the tactics of the worm, it eats the thing. And so it stays there. This is real time, okay? And so it stays there maybe up to 30 seconds, maybe. And it comes out of the river or out of the pond. And now the reason for the film of air is to protect itself, its insulation, okay? Because it's so small. If it were wet, when it comes out of the water, it would catch immediately a flu and die. It's a very fragile animal. So there are different reasons to get this film of air. And my final example will be this extraordinary animal, which is called Argyroneta aquatica. So I don't know if you speak Latin, but Argyroneta has to do with argyros, which is also Greek, which is silver. And silver, indeed, the body is silvery because it's very hydrophobic. So when the spider is underwater, it is covered by a film of air. This is the body. And when you look at the hairs of the body, they are hairy. So it's a very interesting texture. Nobody knows why the hairs are hairy, but it's a fact which makes this spider very hydrophobic. Big difference with Notonecta. I told you Notonecta spends maybe 10 minutes. Argyroneta spends 3 years, okay? Always, constantly living underwater, despite the fact that it has all of a terrestrial spider. And so, of course, this plastron of air is not enough to survive for a few years. And so Notonecta, Argyroneta does something else, which is extraordinary. So here it is. It goes to the surface of the pond, okay? And so it climbs. This is real time. It finds the surface of the pond, and when it reaches this surface, it turns its body upside down, and then it goes out very quickly, and apparently it takes more liquid. And indeed, if you take a very hydrophobic object and you go quickly in this direction. If you go very quick, then this hole has no time to close immediately, and so you trap a large quantity of air. Conversely, if you go very slowly, you only take a plastron of air. So this spider knows that, because it is very quick when it goes out of the surface of the pond to catch a big brick of air, and it does so to build a house of air underwater. And so this is the house under construction, trapped by little plants, and the spider is coming with a brick of air. This brick is put on the house. So now the house is slightly larger. It does typically 20 trips to the surface until the house is large enough to welcome the husband. So I'm very sorry, we are March 8, but it turns out that only the lady is working, okay? The husband is a very lazy person, waiting somewhere until the house is completed. And then they can live, both of them, in this house until a fish passes, okay? And of course agitates a little bit the water, and the house goes to the surface. And the poor lady Argironeta has to rebuild a new house. It builds a few houses per day, okay? So this is the main part of her life. And what she did is what I said. I think it was quite clear in this movie that when she goes out of the house here, so with a new brick of air, which is a big quantity, but she caught at the surface, when she goes out, she goes slowly now, so that she's only covered by a very thin layer. Of course, if not, she would put a brick of air and take the same brick of air out of the house, which is not very efficient. So this amazing spider concludes my talk, and I thank you very much for your attention.
Thank you, Professor Query. That was a really captivating presentation, and I would now request the National Coordinator SPARC, Professor Robibroto Mukherjee, to kindly come on stage and felicitate the guest with an idol of Goddess Durga.
Before I do the honors as the National Coordinator of SPARC, let me also tell Professor Quer that this is the area in which we work. I work on structural superhydrophobicity, sticky hydrophobicity of rose petals, and so on and so forth. So it was just amazing to have you here. And now on behalf of the program, on behalf of our institute, on behalf of our government, it's our pleasure to present you something.
So, because of the paucity of time, we are not addressing any questions from the audience now. So, we would request Shri to take over.
Thank you, everyone. With this, the inauguration session comes to an end. I now request all the guests and participants to kindly proceed for a short tea break, and we'll meet again in 5 minutes.
5 minutes is not possible. So we take a very quick break, maybe 10 to 12 minutes. Time is very short. She's our student, so she still obeys orders very, very critically and clearly. And she's my direct classroom student, so when I told fast 5 minutes, she told that. So 12 minutes, please be back. Next we have a technical session. Also 2 announcements. I have shared the Wi-Fi password to all the participants in the respective WhatsApp groups. And people who want to set up their prototypes, kindly set it up at their respective stalls. And kindly be back in 10 minutes time maybe, because already 2 minutes are gone. Acha, dekho,
Is it possible to change the file? Because I have lecture in the evening, 4 o'clock. still I need to check whether. পরে আমি এটা দেখে নিচ্ছি আছে কিনা আমি ল্যাপটপ আনিনি তাই চেক করে নিচ্ছি যে ফাইল আছে কিনা
তোমার নাম জল জল করছে পার্থ স্যার আমি সেই ভদ্রলোককে তো আমি চিনি
পেন ড্রাইভ আছে
দাও
ওদের না এই ওদেরকে দিয়ে দিন।
কোথায় কোথায় এটাকে ঢুকিয়ে দেখছি আমি এই রে এটা কোথায় কি এটাকে
933
তো যেতে যেতেই 10 মিনিট লেগে যাবে বলছে 10 মিনিটে টিপ রে এরপরে কার তোমার এরপরে আমার টক নাকি না
অন্য অনুষ্ঠান আছে 101
তোমাদের ডাইরেক্টর কোথায় ডাইরেক্টরকে দেখ
হ্যালো 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 আছে হ্যালো হ্যালো চেক হ্যালো আছে হ্যালো হ্যালো আছে হ্যালো এইবার hello hello check hello check hello 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 check huh?
check. Hello, hello. Hello, hello. Hello, check. Hello. Hello. Hello, check. Hello. Check 6. Hello, check. Hello. 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 ঠিক আছে?
হ্যালো হ্যালো যাচ্ছে হ্যালো 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 দুয়ে দে হ্যালো 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 আছে হ্যালো হ্যালো আছে একদম রিয়া আমাদের এই ইনোগ্রেশন আর ওই লাইভটা হয়ে গেল
Now I request everyone to come inside. We are going to start in 2 minutes. I also request everyone to be seated and keep your mobile in silent mode. I request everyone to take your seats. Okay, so
হ্যালো হ্যালো হ্যালো
still morning, so good morning, ladies and gentlemen, again. We are sort of a little bit behaving like Air India, some technical issues. So firstly, we want people to come back. Now, I believe in a philosophy, normally people will keep on shouting inside, please come in, but there is no point in telling people who are already here. So we are making announcements outside. So let people join. Due to very unfortunate reason and a call from the highest level, I am told the Honorable Secretary is unable to make the visit. So our director is on campus now. So we are going to make a bit of change in the schedule. So director should come in a minute or two. So since of course it's a SPARC National Conclave, but alongside that we are also felicitating some of the nation's academic leaders and visionaries. That would be a short session of 20 minutes. It's listed in the program. So we will first do the honoring, and then followed by that, there will be the technical session of 4 very, very eminent speakers, which will be chaired by Professor Vibha Tandon. So little bit of, it's like a Delhi, Jaipur, Bombay flight, but somehow it travels Delhi, Bombay, Jaipur. It's like that. And many of you come from a generation where Doordarshan 1 tagline was very common, Rukavat ke liye khed hai. There is a technical issue. Sorry for it. All the mess I am sure I have done. Nobody else's fault. So just bear with us and follow sort of Newton's first law. Whatever is happening, let it happen. Thank you very much. नेशनल एंथम और ग्रुप फोटो भाई करवा दो। हाँ, बच्चे शुड नॉट गेट। अच्छा, सारे चेयर्स हटा दिए तो ये बैठेंगे कहाँ? अवार्डीज तो है। 3 है। बाद में तो जल्द, हमारे इसका टाइम बहुत शॉर्ट है।
Now, we are delighted to invite Shri Armstrong Pame, Joint Secretary, Department of Higher Education, Ministry of Education, our beloved Director, Professor Suman Chakraborty, along with Professor Rabibrata Mukherjee, National Coordinator SPARC, to kindly grace the dais. Can we have a huge round of applause?
Need any introduction of our sparkling director, Professor Suman Chakraborty, on this SPARC conclave. A huge round of applause for him. One of the finest scientists of the country right now. He started off as a fluid mechanics person, but I don't think any area what he doesn't work now, right now. Can you tell what you don't work on? He doesn't.
I don't work on administration.
Most efficient administration who trusts his colleagues and everything is sort of rooted at our level. Just hold on for a minute. As we said, we are slightly like Air India right now. Just hold on.
We are delighted to invite Shri Armstrong Pame, Joint Secretary, Department of Higher Education. Please have a huge round of applause.
I think I will set the tone for the program because of this delay and the uncertainties. So, Professor Chakraborty, we already had a formal inauguration in the morning in presence of the Joint Secretary. And you were supposed to join now along with the Honorable Secretary, but unfortunately, as you mentioned, he could not make it. So, Professor Chakraborty, I'd request you, as the Director of SPARC and a leading academician of the country who has a lot of international collaborations, to address this gathering.
Good afternoon and welcome to this SPARC Conclave. I was trying to prepare one note with the names of the persons whom I would like to at least mention before starting my little bit of small address. But then I got lost. All the who's who of our education system are present here. Our teachers, teachers of teachers, and possibly beyond that, from first year, second year, whatever we have learned, I see many of them. With whom I will start, I do not know, but possibly Professor Amitabh Ghosh is the senior most present here. And Professor, when we talk about Professor Amitabh Ghosh, our pride is not just an outstanding professor, but he was one of the directors of IIT Kharagpur who transformed the institute in a very positive direction. And I was fortunate enough to be recruited in his era, although I joined in the next era. When we mention Professor Ghosh, we have to mention Professor Mollik. I do not know in whatever way I will tell, but any one of us who have been students of mechanical engineering, if you take a vote, undoubtedly the best teacher of mechanical engineering, at least the IIT system has ever produced, I think no better than Professor Mollik. And then IIT Kanpur story, if I have to continue, then comes a bit younger than them, but a role model to all of us who have started our journey in fluid mechanics by looking up to him, none other than Professor Gautam Biswas. I can still remember that when I was a master student working on some aspects of turbulence modeling, my supervisor, Professor Pradeep Datta of IISc, who could not come physically today because he is on travel to Australia. So he told that if in this country there is one single professor who can solve or who can answer this question, this is Professor Gautam Biswas. And I was desperately looking after him in a conference when he was such a great star that for a student like me, a master student, it was almost impossible to catch hold of him. So we are all immensely thankful to such teachers who have shaped the Indian academics in this way. We have Professor Damodar Acharya with us, our former director. And what more we say about Professor Acharya, he took over IIT Kharagpur's directorship at a time when there was tremendous opportunity but at the same time lots of issues were around. Again, as young faculty, we were very afraid of him. But now I realize that you always have coconut being such a favorite thing. Inside that you have the soft matter and outside the hard matter, and that's what describes Professor Acharya, an outstanding human being. There are others. Oh no, I feel that if I have to look and speak about names, it will just go on. Maybe one or two I will mention. Professor Shantanu Bhattacharya, I have never been his student directly, but IISc, he has been a legendary teacher. Of course, currently everyone knows him as the director of IIT Tirupati. Sorry, IISR Tirupati, right. But the fabulous teacher he has been from our student life, we know. And last I will mention, I wanted to mention many others, but I have noted something I have to tell. Professor Chiranjeev Bhattacharya, Vice Chancellor of Jadavpur University, the university which has made me what I am. So I must recognize, he was a young faculty at the time when I was a student in a different department, so I have never directly attended his class. Nevertheless, I know an outstanding academician, and the university is in very good hands. I would like to welcome one of the topmost fluid dynamists of the world, David Quinn. And we are having him as a guest, not just for this event. I am going to hijack him on my way to Kharagpur today. So next 2 days, he will engage completely with our students on droplet microfluidics and weighting. And I think that is one of the successes, at least, which came out as a derivative of this program. Before I start my address, I express my sincere gratitude to Mr. Armstrong. The way in which you have driven this program over the past years. The SPARC phase 1 could come to the stature of this kind. I would say majority of the credit goes to you. So deep appreciation to your contribution, and of course Professor Ravibroto Mukherjee, being the national coordinator, does all the hard job, and people like us only come to deliver such addresses and vanish. As we stand in our Platinum Jubilee celebration, I welcome all of you, not just the few names that I have mentioned. And I would like that together we reimagine that what we can do in the next phase of SPARC, SPARC 2.0, not as an incremental upgrade, but as a strategic reinvention. And that is purely academic and research oriented, because there is a financial approval that comes. Now, what we do within that is only for the academicians, and that is where we can really create impact. The original SPARC spirit, which was introduced by the then director of IIT Kharagpur, Professor P.P. Chakraborty, and then taken forward, that must remain intact. What were there in the spirit? International academic partnership, joint research excellence, and knowledge exchange. If we just sum up the main points. But over this period of time, the global landscape has changed, and dramatically, as we are towards the end of SPARC phase 1. By this time, we have seen AI-driven discovery cycles, geopolitical reconfiguration of supply chains, climate-linked research urgency, talent mobility asymmetry, and deep tech race among different nations. So with this transformation, we must not merely participate but lead, and the SPARC next phase gives us an opportunity. To make my deliberation very precise and short, I have identified 6 different pillars which I will briefly talk about. Number 1, mission-linked grand challenge clusters. SPARC phase 1 funded projects. And at the end, on the granular level, any such academic activity will be projects. But I would imagine that the new phase of SPARC would fund projects encapsulated in thematic high impact grand challenge clusters, not just incremental projects with exchange visits. For example, the grand challenge clusters may be aligned with climate, affordable healthcare, digital manufacturing, quantum and advanced materials, water, energy, food, and AI for inclusive development. Some of the examples that I have thought. Each cluster can be multinational, multi-institutional, it has to be, why can be, multidisciplinary, and specifically outcome mapped, not isolated proposals, but federated research ecosystems. IIT Kharagpur Vision 2.0 seeks to move from departmental silos to such extensive problem solving where there is absolutely no barrier. Pillar 2, digital twin collaboration platform. Over the period from SPARC 1 to now, digital twins have taken place, the research scenario, in a very emphatic way. Physical mobility is finite, but digital co-creation is infinite. We have to understand that SPARC is about international cooperation, mobility, etc. No matter how much fund is given, there is a limit to it. But digital co-creation can build up on that platform, and then that has immense opportunity. We should build a national SPARC digital research grid with shared high performance computing node, federated data commons, AI assisted collaborative design spaces, and secure IP management layers. Full national grid. Remote labs, joint simulation environments, and shared PhD supervision dashboards. India, in this way, will host the world's first sovereign academic collaboration cloud. It doesn't exist anywhere, and I believe that SPARC has the right platform to do it. This directly aligns with IIT Kharagpur's Platinum Jubilee aspiration, redefining educational technology for scale, inclusivity, and depth. Third pillar, co-supervised global doctoral tracks. Now that SPARC has got the experience of handling the research scholar exchanges in this framework, we should institutionalize dual mentored PhDs who are direct outcomes of such collaboration with a 50-50 supervision model, joint thesis defense framework, cross-border lab immersion, PhD fully on practical immersive achievements with joint IP value addition. IIT Kharagpur in the upcoming Senate meeting is placing this new PhD program, which is PhD purely based on practical activities. The unit of collaboration then shifts from project to scholar. If India wishes to become the knowledge superpower, our doctoral ecosystem must be globally braided. And SPARC makes every PhD a potential global bridge. We must capitalize on this. Pillar 4, translational impact and deep tech acceleration. Research typically in IITs without translation is unfinished work because we are institutes of technology. SPARC 2.0 which we believe that it is going to start, will create joint IP pools, jointly owned patents, international startup incubation, shared prototyping facility, and fast-track regulatory dialogue platforms. We can have a SPARC Deep Tech Acceleration Fund which can seed some of the high impact areas, be climate tech, med tech, agri tech, water tech. Just some examples I am giving. And in our Platinum Jubilee vision, IIT Kharagpur is moving from just publishing papers to publishing papers and building platforms. And SPARC in that way becomes a global multiplier. The central SPARC innovation and entrepreneurship hub may be located at this research park at Kolkata. And as the director of the institute, I commit a particular space if the SPARC National Apex Committee approves this. The pillar 5, equity and global South leadership. The future of the global research cannot be confined to elite corridors. Just before coming here, I was addressing the NPTEL Eastern Zone. There is a big conclave which is happening in Kolkata, only in Salt Lake. And huge number of resource faculty members from different other institutes have gathered. They are all from tier 2, tier 3 institutions. And I echoed the same sentiment that high impact global research cannot be confined only to elite, so-called elite organizations. SPARC 2 will prioritize global South partnerships, enable regional language digital modules. It should, as per our National Education Policy 2020. Create distributed training hubs and provide structured mentorship for emerging institutions who may not be today of that level, but they have aspirations to grow. India will not be a junior partner to the West. Nationally, we will become a convener of the Global South Knowledge Alliance, and this kind of leadership SPARC can provide. Pillar number 6, the last one, accountability through measurable global metrics. Nowadays we talk about ranking, and everyone is concerned about ranking, although we all understand that ranking does not directly reflect the spirit of excellence. But recognizing the importance of such metrics, through SPARC we can track co-authored high impact publications, joint IP filings, student mobility indices, technology readiness level TRL progression, and societal impact indicators. These can be quantitative outcome driven alliances which can help everyone to build up on ranking and branding. So finally, because the SPARC nationally is being handled by IIT Kharagpur, I want to connect it with our Platinum Jubilee vision, which stands on transformative curriculum, inclusive digital engineering, deep tech leadership, women's leadership revolution, and this I must mention because today is the International Women's Day. We have our outstanding women faculty sitting here, women leaders, Professor Tanushree Shahadas Gupta is here around, and Dr. Bibha Tandon, both of them. We are so much, I would say, honored that they are leading two of the major national institutions which are there at Kolkata. And societal scale impact. SPARC aspires to become the global extension of this architecture. when we speak of educating 1 lakh grassroots women leaders, we have just initiated that program through our School of Leadership at IIT Kharagpur. When we speak of digital engineering in regional languages, we are starting a AI-BS program completely in Bangla in the coming academic session. And when we speak of AI for rural healthcare, our AI-enabled cyber-physical systems are impacting rural healthcare up to the last mile, including Sundarbans. And many of these are actually embedded in some of the developments that take place through such research, intense research that happens in SPARC programs. So SPARC ensures the best minds of the world should work, co-create with us, not in isolation, but with a shared purpose. To operationalize this, I think we may require a bit of structural modification. Multi-year rolling thematic calls instead of just maybe a single time-stepped call. Tiered funding, not a flat type of funding. Exploratory, mission mode, translational, depending on that, how the work is progressing, accordingly the funding may be directed. A national SPARC secretariat with complete data analytics framework. Simplified mobility with value-added two-way human resource flow and visa frameworks. Today we have the presence of our consulates from Australia. The highest person from the consulate is here. We have the DAAD representative from the DAAD office. And we had the British Council representative who, because of some work, had to leave. I met him during, as I entered. So we must work together to simplify all these paperwork specific to such exchange visits. And a co-investment model with the industry. If we cannot rope industry, we cannot really come to that flair of industry-academia cooperation that we all imagine through such network. So let us not measure SPARC by simple number churning, number of collaborations, but measure it by the number of problems that we can solve, the technologies that we can actually deploy, be it industry, be it field, the students whom we could transform through such collaboration, and the nations where the science and technology in certain areas could be uplifted because of such collaboration. Let the new phase of SPARC become a platform where ideas travel faster than policies, where talent flows stronger than borders, and research becomes real responsibility, not a tick mark for making your CV. As we enter into our Platinum Jubilee era, we do not ask the world just to collaborate with us, definitely to collaborate with us, but we invite the world through this SPARC initiative to co-build the future on Indian soil, but with global purpose. And the next phase of SPARC in that way leads us to the dream of Vikshit Bharat envisioned by our Honorable Prime Minister, and perhaps that begins now. Thank you. Namaskar. Jai Hind.
Thank you so much, sir, for such an informative talk.
May I now request the dignitaries on dais to unveil the Book of Abstracts on the occasion of this conclave.
Just 1 minute. Our Joint National Coordinator, Professor Sudeshna Sarkar, is now with us. May I request Professor Sudeshna Sarkar also to join us on the dais, please.
A huge round of applause for her. May I now request the dignitaries on dais to unveil the Book of Abstracts on the occasion of this conclave. Now, we will proceed with the felicitation of distinguished academic visionaries. I request Professor Manish Kaushal to announce the names of the awardees.
Thank you. So now I'll invite our Platinum Jubilee Distinguished Academic Visionary. We'll start with Professor Amitabh Ghosh, former Director, Indian Institute of Technology, Kharagpur, former Professor, IIT Kanpur. Then Professor Ashok Kumar Malik, former Professor, IIT Kanpur. Okay. Oh. Hey, yeah. Yes. Professor Ashok Kumar Malik. Professor Ashok Kumar Malik, former Professor, IIT Kanpur. Professor Damodar Acharya, former Director, IIT Kharagpur, former Chairman, AICTE. Professor Gautam Viswas, former Director, IIT Guwahati, former Professor, IIT Kanpur. Professor Vibha Tandon, Director, CSIR, Indian Institute of Chemical Biology. Professor Tanushree Sahadas Gupta, Director, SN Bose National Center for Basic Sciences. Professor Bikramjit Basu, Director CSIR, sorry, Director CGCRI, it's a mistake. हटा देना. एक दीपेंद्र में.
Professor Shantanu Bhattacharya, Director, ISER Tirupati. Professor Chiranjeev Bhattacharya, Jadavpur University. थोड़ा रिसाइकिल मोड में अपन करा दो. और एक चाहिए, और एक चाहिए. Just one more. Professor Dipendra Mitra former professor of AIIMS, New Delhi. He is last and certainly the most important because he's a doctor par excellence, and all the SPARC PIs needs to be live long to do all the work Suman has just mentioned. And we will grant him a special project, health monitoring, including mental health of all SPARC PIs and the national coordinator. You want the director Kharagpur to be included in the list? So we will now have a group photograph on the dais with the dignitaries. Sir. Mr. Pame, Suman, myself and Professor Sarkar will stand. At the back. Amra pechune darabo. Coach, technical director, etal. Coach, 11, football team. 11, full team. These are the coach, technical director.
Now I request the awardees to take their respective seats among the audience.
I would also like to request the PI sitting on that side to kindly compress, because now we will have a group pic with the full audience. So cameras have limit of being wide range, so please understand what I mean. So people in the last set, you may please shift here.
Moving on, I request Professor Sudeshna Sarkar, Joint National Coordinator of SPARC, to give her vote of thanks.
Director IIT Kharagpur, Professor Shuman Chakraborty, will address for a few minutes.
Not for a few minutes, just very briefly. I have this responsibility of conveying to this audience that Honorable Higher Education Secretary Dr. Vinit Joshi, he was supposed to be there in this program, but because of a very high level engagement which suddenly came up at the highest authority of the country, he could not come, but he has personally conveyed his deepest respect to 3 of the teachers who have taught him directly, and whatever he is because of their outstanding contributions. Professor Amitava Ghosh, Professor Ashok Kumar Mullik and Professor Gautam Biswas. When Dr. Joshi was a BTech student at IIT Kanpur, they 3 were his teachers. I thought I must convey this because he could not come today physically.
So as this special Platinum Jubilee session comes to a close, it is our distinct privilege to have hosted this session, and our sincere and heartfelt thanks to the dignitaries of this session, Director IIT Kharagpur, and special thanks to the eminent academic visionaries who have taken a leading part in the research, in education, as well as in the institution building of this country and shaping Indian academia. Our heartfelt thanks for having this opportunity to honor some of the important educational leaders in our country, in India today. I also, on behalf of the SPARC organizing committee, I also have the thanks for the director for his inspiring talk about the different schemes and the future of the SPARC projects and the different projects that IIT Kharagpur is unveiling in this Platinum Jubilee year for the bettering of education, outreach, and also for different initiatives that the director has addressed for the special occasion of Women's Day. I also thank all the participating scholars, the principal investigators, the dignitaries, friends of SPARC who have gathered today to take part in this SPARC academic conclave. So I hope for the remaining 2 days, you would have a very engaging time, as you see the showcase of research and different discussions that we'll be holding for SPARC. Thank you very much.
Thank you, ma'am. I now request the audience to rise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे।
Now I request the dignitaries on the dais to join the audience for the SPARC group photograph.
So we will have a group photograph on that side so that all of us come, and maybe it's not a bad idea to rise again so that you are all clearly visible. And compress a little bit, because I really have whatever is the best quality DSLR, it has some limitation in the limit, the range. And somehow due to optical illusion, people on the sides look a little fatter, huh?
দাদা হয়ে গেলে বলবে।
I request everyone to kindly be seated. Kindly be seated.